Intro Algebra Lesson 5-1A. Now that we've been looking at different slope-intercept form and other linear equations, we want to see if we can take that concept and apply it to something in the real world. And that concept in math is known as a linear model. So in a linear model, linear still meaning a straight line, a model just representing what could happen in real life, is going to be a linear function used to model a real-life situation. In M, which we know as slope, is now referred to as the rate of change because it's something that's changing over time. Typically, and not always, but one of the key words you can look for is the word per. So if you want to know what might be the slope, look for the word per. Sometimes that's an indicator of the slope or the rate of change. For example, the rate of change or slope for a gas problem would be how much you're paying at the pump. So if you're paying $3.40 per gallon, that's the rate of change. And the price changes according to how many gallons you buy. B, in this case, is going to be your starting initial amount. That's the B value, which we know is the y-intercept. So you always start at whatever amount's being put into the bank account, how much you borrowed. That's your amount that you start at, and then you change from that location. In other words, your rise over run, whatever the per or rate of change amount is. All right? So when it comes to making these equations, for example, let's say you invest $50 in the bank, and you add $30 per month. When you say invest is your starting amount. You've put $50 into the bank account. Then you add $30 per month. That sounds a lot like your slope. So this would be our M. Terrible M. This would be our M. And this would be our B. We're starting at 50. So y equals mx plus b. Tell me exactly where things go. Y equals 30x plus 50. So you started at 50, that's your initial starting amount, which is B, and your rate of change is $30 per month, so the 30 goes in for M. And that's how easy it can be now that you know slope-intercept form. Let's try another problem. Write an equation of the line whose slope M is 3/4 and whose y-intercept is B, -4. We know we're using y equals mx plus b. There's two pieces of information we need. We need this slope to go here, and we know the y-intercept has to go there. So now it just becomes a matter of writing the equation. Our slope is 3/4. And our b is -4. Writing an equation can be very easy if you're given two key pieces of information: the slope and the y-intercept. Right? Lastly, write an equation from the following graph. Now, last time we wrote an equation, I was very frank. I gave you exactly the slope and I gave you exactly the y-intercept. This time, I'm not going to give you that information in the same format. This time, I'm giving you a graph. But if you think about it, I'm still presenting you with the same information. Last time, you needed the y-intercept. This time, you can recognize right there is your y-intercept at -1. Well, that's an important piece of information. Last time, I gave you the slope. It was rise over run, 3/4. This time, now it goes down 1 and right 2. So if it goes down 1 and right 2, now you have a slope of -1 over 2. Down 1, right 2. So that's the slope. You have the slope and the y-intercept. Y equals mx plus b. You now have y equals -1/2 x plus -1. And you've written an equation that represents that line because you know the two most important pieces of information for that line. You know the slope, down and over, and you know the y-intercept. If someone had chosen to go up 1 and left 2, then they would have just had up 1 and left 2, which is really no different than this right here. So either slope is the same. And that's how easy it is to write a linear model based on either real-life situations. You can determine what your starting amount for b is and what your rate of change is for your m, your slope. And you can write the equation from y equals mx plus b. And you can do the same when you're given those values. Or even if the information is presented differently and you have to take it off of a graph, you still know the y-intercept and you still know the slope. So it's easy to write the equation.